Right, let's take a look at this problem. Count unique characters of all substrings of a given string. Let's define a function count unique characters that returns the number of unique characters on S. Alright. Okay, it returns 5. Given a string S, returns sum of count unique characters, where T is a substring of S. Notice that the substring can be repeated, and so in this case you have to count repeated ones too. Okay. Okay. You can have A. Okay. So okay. So we are looking for substring with only unique letters, and they're to be ordered. Okay, what is this? So this is ABA because A, B, A. No, A, B. Uh, ABA, AB, AB, BA, A. No, not A, but okay. So here we have A, B, A. I have to perform 5 more. 1, 2, 3. The same as example. B. So it would be A, B, A. A, B. So this is the length, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Some of their lengths. Except count this. So you have A, B, A. So you have A, B, A, A, B, B, A. And that's it, right? A, B, A. So every possible substring okay. But there is no such function like this, right? Return count unique characters ABC. Okay, that's not defined, alright. So, I thought that maybe it's built in. Okay, so we can just have every possible combination here, and not combination, but like, yeah, substring, every possible substring. In that case, we will look at how do we increase? So I start from A. So if we have some sort of tree, I have A, I go AB, I go ABC, and I go B, BC, and go like that. And at each level, we perform this count sort. Not count sort, but like count unique characters. So if we have some sort of tree with every node in a tree has some hash table of the characters, different characters. In that case, we would have something like the tree's height, and also in every height we were adding a character to it, so it would be like from every word, the length of the word times actually it might be n square, but okay, we'll think about it later. So for now, I'm gonna assume that like this is, I think, my only solution there. Of course, I think it is possible to cache it while recursing. So I prefer to do memorization and caching. Memorization and recursing. Yeah, so I want to recurse depth first search or something like that to generate all possible substrings. While doing that, I will keep track of unique characters and add to the result. Okay, so I will just define my DFS. I don't have to pass. What do I have to pass? Let's see. So remaining string. I have to pass the remaining current string, current dictionary, characters. I have to pass s, or like, so here, let's think. Maybe I just pass remaining string. Okay, I pass s like this. My current string is always changing. I will be adding those. My current characters are the ones, basically my like cache mechanism or something like that, because I'll be passing that and then searching in that. And I think that is how this should work. Then what's the, so if remaining string is empty, then I just want to stop. Maybe add the last one. So the length of, yeah, each time. Results, yeah, I'm going to also add that. So so results 0 plus equal length of current characters, and then return. So this will be my base case. So I'll go down, down, down. At the end, I want to return at this position. And then for every character in remaining string, we create a new remaining str will be remaining. So I guess here for every I in range length of remaining string, we'll just do this. So remaining str, new remaining string will be the one excluded from it. So until I just remove that, plus remaining string I plus 1. I don't include I there. I don't include I there too. And then new current string will be okay, so it will be remaining string I. Actually, no. Current string plus I, because we want to add that. Okay. 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 And then dfs new remaining string, new current string, current characters will be remain str plus rem stri. No, actually here how do I do this? I'll pass the dictionary. Maybe backtrack, edit here, and then remove it later on. Right. What if I have a what if I have this A, B, C, A, B, C. So from A to A, I have one unique character here. I have two, I have three. From B to A, I don't have anything. I don't have anything. I don't have anything. B to A, I don't have BA, right? And come here, I have B to B, it is 1. And from B to C, B to C it is 2 characters. And then later on it's just 1 here. Wait, this is much simpler. But if I have A here, A here, come here, this is 1, BA, so from this side to that side, it's now 2 again. Wait, it is from this A to B to A, it is 1. From this to there, it is 1. So this is 1 here. But for every one of them, so this is n square, but for every one of them we have to, yeah, I think my initial approach is wrong. So if, yeah, this is much better because we're storing values and passing those. And also, I know that I want to look at the words between this and that, but maybe Okay. Okay, let's see. I'll just delete this. That. Alright. So left to right, or we're going from left to right. Just check it and then add it. So here I'm simply going from this side to here, taking it, and now checking if it exists. If that character exists, we decrease it. If not, we increase it. Right? So yeah. Or wait, what if I have like one more A here? Then that would be from BA. I decrease it from A to A. I only have one. A to A. I don't decrease it here because I can have like A like that, A like that. So what if I have return like 8 plus 1, 11. So if I have like this 18, it is 18. And why is that? B from B to A to A. You also take it from here. B to A. So you have 8. Now you should have okay. What are the values here? If I add them, so I can have BA, BAA, BA, BAA. This will be 1. From A to A, it will be also 1. B from B to A, you have 1. Wait. So you have 1, 1. If it is the same, you have 1. Increase, increase. If it is the same, you have 2. You then change the previous one. If you have the same, you have 2. But wait, if that's the case, you have the same, you have 1. From A, the only unique one in this part is 1. The only unique one in this is 1. The unique one here is 1. Unique one here is just 1. Oh, I forget that this was 1. This was also 1. So if we encounter the same thing, we shouldn't decrease here. But we have to decrease. 1, 2, 3, 4, 5, 6, 7, 8. That is 10. AB's. Oh, it should be 11, right? Not 11, but 12. Let's see. Just give me a second. So here it will be 1. I decrease it. For 1 again. From here, so at this position, I check if from this location or like this index from J. So at here, I do this check. S from J to I, which is that one, which is 2 plus 1. Okay, is unique, is like making it like unique check here, unique. If it is not, then we decrease it, or like, yeah. If it is in, we don't. If it is 1, we decrease it. Okay, equal 1 minus 1, else same. So here, this one is not 1, A. So dictionary, I look at the dictionary at this level, and come here. Again, this is the same. From this position, I go in, increase, because it's not in the dictionary. I go in, I decrease, like that, and then same. This is 1. Again, from AA, it is 1. I go in, A is 1. I normally should decrease, but yeah, here is a problem. AA, you should, yeah, increase it and decrease it. In this one, we didn't think, we decreased by 1. This one, we decreased. We shouldn't decrease. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 12. It should be 12, right? Not 12. I guess this is 0. Like this. 11. 1, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I guess I find my. Yeah, I found my relation. So, okay, it's been how many minutes? 20 minutes. But I think it's much easier to implement it now. So, I'll need a dictionary. But I'll need that dictionary in each row. So I will initialize it there. Okay, so I'm just going to create this string matrix. My matrix will be here. It will be 1 at start for every I in priority j in range length as, I'm gonna call it n. Okay, and then for every I in range n, and then I filled it with 1. Actually, I should fill it with 0 because this should be staying the same. Yeah. So then I will have for similarly for j in range like this. So here the thing is that so if I and j is equal, then it is just 1. J is equal to 1. And also here I want to have this here I want to have if I is, so if j is greater than or equal to I, because I don't want that otherwise. And here else if we check, actually this is just else, we check if, so here in each one of them I will have my dictionary like this. So if my dictionary if I have my j in dictionary, something in else, something else, if I have it in my dictionary and okay, and dictionary sj is 1, if it's 1, I want to dictionary sj, I decrease it. Wait, what is this? And I also want to matrix ij, I should decrease it. Like should be equal to mat I and j minus 1 minus 1, else it is the same. I'm gonna change anything. Okay, and here if it is not in the dictionary, then I want to add the previous one, add 1 to the previous one. So it should be like this. Add 1 to the previous one, like that, and it goes on like that. And okay, so in the end, I'll just return the sum of this, but you can simply have this output 0 at start. Come here when I increase it, when I decrease it, output that. Well, actually, after every loop, after every item, I have to add that. So I may make this, so if it is not in I just make it like that. And then later on come here, it is in dictionary. If it is not in the dictionary, I here do that, and then dictionary sj should be equal to true, and also here maybe this should be 1. It should be 1 here. If it is not in, if it is in the dictionary, I decrease it like that. And also here else dictionary, I want to increase it by 1. Yeah, so here, from here, I come here, dictionary, I add it into the dictionary. I have my a equal to 1 in my dictionary, and then I come to b, I come here, it is not here, I just come here, this one. Now I just have b equal to 1, and then I come to a, I come here, it is in the dictionary, it is just 1. I should increase it by 1. Okay, I increase it no matter what, so it's like that. But if it is 1, I decrease it. Okay, so I just make this 2, and then again same thing, I come here, it is not 1, I don't decrease it, it stays the same, but I increase my count. This is now 3, I give 1 to there, so it is the same thing here. Actually here, so the default should be, actually it should be 1, no, it should be 0, but here else it should stay the same. Okay, like that. I just pass it from left to right. Now I go down, I'm at this, I give it 1, my dictionary is now only b, like that. Now later on I come here, put a here in, and then +1 because it is something different, that is not in the dictionary. And then I come back here, I think it should work now. So what is the output? So I have a syntax error because that's, it returns that. Actually I'm curious about my print matrix. Let's see. Now I have 1, oh wait. What? Oh. No, wait. Wait, how is this possible? 2111, 211, 11. Wait. Okay, I mean it works like that. That's correct. That's one. I'm confused. All right. One small typo is going to kill me. Okay, let's try this. Okay, that's cool. I mean, if that works, I guess everything works. Let's see. Ooh, it says thumb limit exceed. Well, that's a long one. But well, anything I can do here. Well, so every time I'm building, so I'm not. So let's see. From here to there, I don't get anything, right? Here to there. So from here to there, I can maybe pass like from here to there. Or I don't know. I mean, if I pass something, I mean, it is just n squared. Why am I still getting this problem? Okay. Do I have? Let's put it in. From this A to this one. What do we do? Okay. All right. So if I find some sort of passing between rows, I think we won't. We'll handle this time limit exceed. But that's it's actually weird because this is like n squared solution, and I'm stuck with this TLA E. Okay. So maybe I mean, like, all right. So we calculate that. All right. This is the maximum we can get. What if you had like A, B, C, D? Then that would be, yeah, that would be 4, 5, 5, 10. And then from B, C, D, you can have 1, 2, 3. Which means that you subtract every one from everything. And here, same thing happens. But if that is something that is making that unique. So okay, for every row we calculate the dictionary, but then actually we calculate the dictionary when we calculate the first row, right, with this, then from top to bottom, right, top to bottom, well, it's really hard to, so if I find something like this, A, B, A, to B, A. So this is 6, this is actually 5. And this is 4. And then A. If I find some kind of relation here, this is just 1. And then here, to A, this is just 1. So if I find a relation here, I think so it will be much easier. What about that? So if I have A, B, C, D, this will be 10. B, C, D. This is 6. Right, 1, 2, 3. Now it is C, D. This is just 3. Now D. This is just 1. Okay. So if it is something unique, subtract the length, right? If it is something that is not unique, let's consider this. Let's say that B is here. A, B. Okay. E, A. Then it would be 1, 2, 1. 1 to 1 is 4. So, okay. Then you have a B here. Again, from there. So if it is something not like that, you just decrease it by 1. If it is something that is making 1, 2, 1, 2, 2, makes it 3. Okay, this is just 1 now. Alright, I think I got the pattern. If it is something that is not making it unique, you just decrease it by 1. If it is something that is making it unique, then you are decreasing for the next one, you're decreasing it by length of it. Okay. Good, okay. Oh my god, it's 50 minutes. So, right, I'm gonna take this. Similarly, okay, same thing. I don't need this range. Okay, I need this. They something like this. Okay. Alright, so everything J. I don't need this. Okay, if they are equal, for the first one, it should actually start from 1. Actually, this will be my output. Like current unique. Score will be 0. It will be actually 1 from the first one. I just start from there, go until the end of it, and then if it is equal to, so I will have a dictionary here, dictionary, or like if I have a counter, no, I think I need a dictionary for this. Okay, right, so I'll start from 0, dictionary like that. Here, SJ, if SJ in dictionary, if it is not, then unique score add unique score plus 1. Priv score is 0. So I have previous score. Score table. Maybe something like this. And 0 for for I in range and we just go over it. Yeah, for j in range. So for j, so sj in dictionary, if it is not, okay. Actually, I'm just gonna put it here, one like this, and then the first character as 0 should be starting with 1. I put the first one in, and then I come here, score table, yeah, and also score table 0 should be 1. Start from 0 and it should be 1. So now, if sj in dictionary, now dictionary sj is 1, I check it. Now I make it like here, score table. Now score table minus j minus 1. From the previous one, it should be minus 1. Else I edit like that. And if dictionary sj, I also add that one. Otherwise, here I come here, current unique score table j. Else, yeah, it should be just the previous one, j minus 1 plus 1. And I initialize it here like that. And then I put, so here I done it this, print or like return score table, some score table. So let's try this. It should be actually, yeah, ABAA should return me, oops, okay, should return me 1, 2, it should return me 5. Okay, it is returning me 5, so I have my first row. In the second row, when I go with the next one iterations, so I will have my for loop here for every I in range. Okay. And so if the dictionary count is 1, so there are two possibilities, like I said. If it was in the dictionary, two possibilities. If we remove and that character becomes unique, else remove and that character is still not unique. So let's check. So if it is still not unique, we minus 1. So score table. So I don't return this. Current score is that. Score table plus equal minus 1. So I'll just decrease it. 1 current score. And then here, current score will be the length of Actually, it's just n minus I here. I is 1. Yes, at the end it will be 1. That's the length here. I will be here 3. So at start it's 0. The n is the length of the string, I minus 4, and then here at the end score table I add that. Okay, so this is actually the total score output. Let's put it from here to there. Let's try it. Okay, how do we ensure that? So if we remove it, and if we check here, we remove that character becomes unique. So if the dictionary sj plus I is equal to 2, right? And we come here, dictionary si is now 1, else no matter what we decrease it, right? We can just put it like this. I don't need this. So if it is 2, I decrease it to 1, and it makes it, now it is unique, so I just do this operation. And if it is not unique, it still decrease it by 1, but we have this. So it is now 13. And why is that? So let's print current score. So it is 5. Let's print the current score. Wait, what is this? Poetry. Okay. So what is this? I have 1, 2, 3, 4, 5. I start from 0. Actually, this should be 0, and I should add this just before it. And also print it here. Let's see now. I have 1, 5, 4. It shouldn't be 3. Now it just becomes 3. So I just remove it, and from here it's not 2. So we are at I, which is 0. I first add it to my result, and I want to remove that. I come here, decrease the score by 1, come here, that's not something unique, I decrease it by 1, that's correct. Now I want to decrease it by the length of it, because if I remove something unique, I just remove it, now it becomes 1. At the end, remove character is still not unique. Wait, it's actually no. So let's see. Else, okay. Let's see. From 3 to 1. Okay. Let's see. From AA. So if it is not unique. But it should never go below 0, right? I think that was my problem. So if your score I want to do this if this is the case. Let's try something different. A, B, C, D. And let's try LeetCode. Oh no. Oh no. LeetCode. Okay. One, two, one, two, 3, 4, 5, 4, 7, 9, 16, 22. 6, 10, 19, 22. What's this? 2, 3. 3, 2, 3, 4, 5. It is 23, and that might be the reason why it is wrong. Wait, what? If it is greater than or equal to. If it is something unique. In the next one, one. This is actually wrong. This should be 1, 2, 3, right? 1, 2, 3. So this was making it unique. Get rid of that. Get rid of that. Six, 2, 3. If something unique. Six, 10, 19. 19 to 6, 6, 12. 2. From, yeah, it's actually if it is something unique. Okay, my calculation is wrong here. this one, this if is wrong. Um, okay. What if I cache it? Now, what's the time? I'll take a look at the answers, I guess. What? One pass. Actually, I was going to do that, like with this. This is just one pass, and this will be one pass. Yeah, but they're all often. Yeah, I'll probably check it. It's pretty. Yeah, I don't know. Okay, I'll just stop here. Maybe find a solution and continue with this video. Yeah, I'll just pause it now. All right, so I checked Lee's solution, and I understood it, and I think this is a really different way of solving this problem, because so let's go over this example. So basically, if you want to know the possible how, like, if you want this to be unique, this A to be unique, it has to be split between this, right? We don't want the other A's. So if we calculate all possible unique character uh, substrings, right, for every character, then if when at the end, if we sum them, we will have our result. So it is basically that idea, but here, as you see, for step one, so we have to determine where to put this. So we can put this parenthesis, we can split it here, or we can just split it after x, like this. We have two possibilities. And also we can have these parentheses, like we can just take a, we can just take ax, we can take axx. So we have two possibilities from two different possibilities, and when we multiply these, we will have so 6 ways to make a second a unique character in a substring. So, like, in other words, there are only 6 substrings in which a contribute 1 point as a unique string, and this a is the second a here. And if we do this for every character, we will have every how many points every character contribute to as a unique string. And instead of counting all unique characters and struggling with the possible substrings, we just count for every character. We can do this operation, and then we just add all possible ways to the sum, and then that will be our answer. And this is the explanation for this solution. And here, so we basically have to hold the previous and previous, like two previous index, and also hold the previous index so that we can calculate this. So if you want to calculate this, you need the previous index A and the current index, or the next index A. But if we just shift our focus to, like, if we continue with the, like, how do we do it with the one pass, because we don't want to do from here A to, we don't want to go back and front. But if we are here, every time we change the previous and the previous, and we shift that array values. So the shifting is here. We just put the current and then the previous we got from index to there. And we also calculate the current index, like we calculate the differences between, so this difference, so left difference, and where is that? So left difference and right difference, right possibilities, and we left and right. I'm sorry, this is right, this is left, and actually just let me put it here like that, and then yeah, so it's better. So this is left, this is right, and then we put it in result for that character, every possible unique strings, and then we update the index. In the end, we will have remaining ones like this A, right? And sorry, just 1 second. And then yeah, we will have some remainings, and we will have to perform same operation on those with the last index as the current index. So again, I want to put this just here like that, because this is the right side and this is the left side, so it's better to see it. All right, so that is the answer of Lee. Actually, my answer also works. The brute force approach is n square. My initial the second approach, or is that? So this is of n square, which is also of n square space, but this is just of n width of one space, because it is just 1/6 list items. So the time complexity is of n, but the space complexity is just of 1. So that is pretty good solution to this problem. All right, so yeah, thank you, Lee, for this problem and explanation, I guess, because like I wasn't able to solve it in all of n times, but all right, so that's my yeah, that's the optimal solution there. Not my solution, but yeah, I finally understood it. All right, so that was it.